Welcome back. So with our previous modules that we have covered, we are now familiar with industrial robots technical specification, forward and inverse kinematics of such robots. So with that, we are technically now ready to start learning something very practical right from the beginning when these robots are installed in any industrial shop floor. Not just an industry, quite a lot of universities also nowadays they have industrial robots in their lab. To begin with, I'll start with very low payload capacity robot of something around 10 to 15 kg payload capacity, which are quite good to do pick and place kind of robotic jobs, welding job, painting job. So small scale jobs can be taken up by such robots. So in today's lecture, I'll be just discussing about installation and commissioning of one such robot. Pre-installation tasks are few tasks which are required before installation of these robots to any floor. So we'll just start with that. So when a robot is delivered after a long transportation from maybe a foreign country or maybe from the manufacturing site, they come very much like in a collapsed form, something like this, which are known as a transport state of this robot or a home state, which are transportation state. So in this condition, this robot has its CG, which is very much in line with its major axis, and weights are not very much distributed. It is very much focused and towards the center of this structure. Okay, so that makes it very stable and easy to transport. In such a collapsed state, they can be easily put in a huge container. And apart from that, they are also fitted with a type of clamp somewhere on this robot, or maybe a mounting frame which is there so that you can hold it, lift it and transport it during the transportation. This is one such part which is fitted in Yaskawa GP12 robot, the one that we have recently installed in our lab. So this is a mounting bracket which is there. So it goes to the real robot somewhere over here. It is bolted to the robot and it comes something at this region. Okay, at this region it is there. I'll show you the actual picture and the videos that actually shows this particular part fitted on top of robot, which was later removed. So yes, this is how it looks like. It is just a skeletal picture of such robot. So let's start. So we'll just have to remove such shipping bracket, okay, because now that it has come to our site, we'll have to remove it so that even by mistake we should not start the robot moving. Okay, so that is why this is to be removed. So all major transportation is now over. It can be lifted using just small shackles which are there. Okay, so apart from that, installation of safety fence is very important at the manufacturing site. It is requirement of ISO 10218, that is safety requirement for industrial robot. This is the standard that tells it that you should have proper barrier. You can have interlocks. Interlocks are kind of switches which are installed in the robot so that as long as a person is there within the workspace of the robot, it may have some kind of proximity sensor, physical limit switches or door closer switches, so that it comes to know that a person is there inside the work cell of this robot. It doesn't allow you to start the robot. So that kind of interlocks are there. Perimeter guarding can be there. Perimeter guarding is something like this. I'll show you in this picture also. So you see, you have a very good guarding which is there throughout, like a red strip which is there, although it cannot prevent a person falling inside this cage, but yes, it is quite good enough to make you understand that from here your work area actually started and it is not safe to get into this area. Okay, and you may have some bright stickers which are there on the floor. Okay, apart from that, you can have awareness poster all around the workspace so that people are aware that you should not enter, because these robots are very much like a beast. Okay, so you should not enter into these areas so that yes, it can even kill you. So they are very dangerous. They are powerful robots. Okay, so there are signals As long as the robot is running, they have signals in that workspace, red, green, orange, like that. Okay, that can be switched on when required, during maintenance, during operation, and when it is halted. You should be very much aware by going through its technical manual, which are provided by the manufacturer, that how much is the maximum horizontal and vertical manipulator reaction forces and torque that can come upon pressing emergency stop or while it is accelerating or decelerating. These are the instances when it can generate the maximum horizontal and vertical forces and torques. Okay, so they are mentioned in the data sheet or in the technical installation manual or system integrators manual of these kind of robots. So they will precisely specify how much are these values. So you should be careful while you design your concrete structure or wherever you are going to mount this robot. Okay, they are usually 5 to 10 times of the robot weight. So use of correct tools, that is very, very important. You should not use some very much like off the way tools, like it. You cannot use spanners to handle something, to hammer it. Okay, so those precautions should be taken. Fixtures should be well planned. Okay, before installation, how you will lift it, how you will align it to the boards, and you will place in the proper location. Okay, and the procedures are very well suggested in the robot manufacturer's manual. So those should be gone through before installation. Okay, and you also check the robot's end effector flange dimension, so that you can procure a proper gripper or end effector tool. It may be a welding, it may be just a 2-fingered gripper or a 3-fingered gripper. It can be a painting gun, welding gun. So that flange should match. We have discussed enough while we were discussing the technical specifications of these robots. Okay, and use of cable harnesses should be done. Okay, you see this is the cable. Okay, so cable harnesses are provided by the robot manufacturer also. The standard ones, the cables that are used for the robot functioning, they are provided. So you see it goes here. Let's say you have fitted a welding gun, so you need to pass your welding cables and all. So in case of robot like Yaskawa GP12, it has a center hole. I'll show you in the video also, that allows passing the cables through this hole. Okay, airlines, that is to handle the pneumatic gripper if you have welding provisions. So all those wires can be properly harnessed so that they don't obstruct the robot while it is moving, and if it gets entangled, your robot may get totally non-functional. Okay, protection against dust and moisture. You should follow the IP class that is there for the wrist and the robot body. Your wrist may have IP54 class, whereas your rest of the body may be of a lower grade also, or maybe your IP67 or higher is there at the end effector, whereas your wrist and the rest of the body is of lower class, IP54 or something like that. So you have to understand properly before you put them to use. Proper enclosures should be there for the rest of the robot, like painting robot. You have seen in the video while we were introducing the robot's application, you have seen that it was properly enclosed well. So it was put with a wrapper all over the robot. Dedicated earth pits should be there because it should see a proper ground with a resistance less than 100 ohms between the robot controller and the ground potential. And equipotential bonding should be there between the robot and the controller. So dedicated wires are there to make them all equipotential, so that the phases, the electrical signal should go in a proper way. Okay. Prescribed concrete platform should be there. The platform on which it is mounted, that should be as per the guidelines which are there in the manufacturer's manual. So I'll show you those exact specifications for one such concrete platform that we have built, while I'll be showing you pictures and the videos of that. Foundation and the anchor bolts which are used for the mountings. Okay, so these are to be taken care of. And appropriate support, if at all it is mounted upside down. So you see there are some structures which are here that holds it even in case of, let's say, bolt failure or breakage. Okay, the robot will not fall upside down when it is upside down. Even when it is inclined or on the wall, it should be taken care of. Okay, and do not weld. This is very, very important. Any of the robot structure or the foundations are not welded, because that can cause material failures. Okay, configure the axis specific and Cartesian specific workspace software limits. If at all it is required, sometimes your workspace, let's say your robot can go within this workspace, some forward region, or this much area it can cover, this shaded area from here to here it can go. If at all you have some object which is placed in this region, okay, then you can make your software limit in axis 1 so that it can go only till here. Got it? So that you don't hit the object. So unavoidable any sort of structure which is there in the robot space, so can be avoided. Even by mistake you cannot program the robot to go there. Similarly, you can have some workspace in the robot area also where the robot cannot go, by specifying the maximum and minimum limits, x min, x max, y min, y max, z min, z max. Those limits can be placed in the workspace so that the robot doesn't enter into this volume, or robot can work only within that volume and it doesn't go outside that workspace. So these are something which can be done. Okay, and put any supplementary load or peripheral equipment which are necessary for this robot to run or do its some kind of function on the designated arm or the body area which is marked in the robot's manual also. So only those areas are to be used. I have discussed about this even while I was discussing the robot technical specifications. So I'll show you that in the figures also. So yes, you should understand the robot work envelope. How much is the maximum reach? Okay, so that you can put the physical barrier over there, and if required you can put dedicated sensors which can sense any human until that area. Proximity switches or kind of door locks or enclosure or even the cage can be put within that area. Same is the case in the front, in the back and the top. So whole of the workspace can be enclosed well, can be taken care of well. So understand, by looking at the data sheet, you have to include the tool that is mounted at the end also. Okay, and it should be operated by the trained personnel only and follow the safety procedures which are mentioned in the robot's manual. Okay, so there are few important steps for installation and startup. Okay, before you actually start the controller and make the robot move, these are few important things that you should note. So you should carry on visual inspection inside the controller, on the robot and the motor, any electrical spaces, or sometimes you should look for any damage that might have happened while it was in transport. Okay, and check for any condensation if it has occurred on the circuit boards which are there inside the controller. So visual inspection helps a lot. It is not always that robot starts and it indicates through some kind of failure. So it is very, very useful. Okay, constructing the mounting base, mounting plates and the booster frame. Sometimes robots are not just mounted on a concrete floor. If it is to be mounted quite high, so dedicated booster frames are there. Even when it is mounted inclined on the wall or on the floor, this kind of booster frames are there on which the robot can be mounted. Some standard plates are there also. I'll show you that we have used. Okay, so construction of that is to be done. Okay, check for the proper phase sequence. Sometimes robots are 3-phase robots, so your electrical phase should be correct. All the red, green and blue phases, or you call it 3-phase electrical connection, should be in proper sequence. It cannot be like this. That can be easily understood by checking the direction of rotation of the cooling fans if it is there. So cooling fans also uses the same electricity. So direction may go reverse if at all this phase is reversed. Okay, so without this your robot will not start also. Okay, use dedicated cables that are provided by the manufacturer to connect the robot, controller, teach pendant. Any input and output is not normally provided by the manufacturer. It can be a third party device, but you should conform to the guidelines given by the manufacturer of the robot as well as to the manufacturer of the IO systems which are there. Let's say if it is DeviceNet, Profibus, whatever it is. So you should take care of that. Okay, do configurations for input and output that is required for all the input and output. By default it is not configured to be used in your robot programming, so that needs to be configured. Any attachment that comes apart from the robot controller dedicated IO, so needs to be configured. So that has to be done before you start. And this is something very important. Sometimes during transport robot might have got stuck somewhere or it might have hit anywhere, so it may require something which is known as mastering of the robot. Okay, so this is a very specific procedure which is to be followed in order to do mastering. We'll cover this in a separate module also. So it has to be done with and without the load. If at all a robot is pre-mastered, normally it comes, smaller robots, it comes pre-mastered from the manufacturing side directly to your university. So it can directly be put to use without actually doing mastering. It can be done by electronic procedure, or there are some inbuilt software techniques that allows you doing self-mastering of the robot before it starts for the first time. Okay, so that can be done. Okay, so and you need to calibrate your tool center point. So that is the center point of the end effector tool needs to be calibrated before it is put to use, because by default your robot knows its flange but it doesn't know the tip of the tool. So while moving, that is to be taught to the robot where it is, how it is oriented. Okay, base of the robot, fixed tool if it is there on the workspace, within the workspace, that needs to be precisely located and known to the controller. So you need some sort of calibration to do that. Your workpiece needs to be calibrated. All the calibration procedure will again cover it in a separate module. Okay, so that will be doing also in a separate lecture. I will be doing it. Okay, so and enter the load data. So robot by default again it knows the moment of inertia, masses of its own length, but whatever tools and mountings that you add on top of this robot, it doesn't have any information about that. So that needs to be calibrated and entered to the robot controller so that it can perform its best. Okay, and you need to jog all the robot axis before you actually make it run, program the robot. Okay, and when you program, you should run at the slow speed first. Okay, test, do some trial runs across the workspace. Okay, then you put that to use. Okay, so before we move ahead, so I'll just show you some video demonstration. Along with that, I'll explain rest of the things. So let me start this video first. Okay, so this is the robot. And you see it has this yellow frame that I was talking about. So this is the frame which is used to transport this robot to this long distance. Okay, and you see there is a hole at the rear part of this robot. This is the place where all the welding harness can pass, your pneumatic lines can pass, whereas all the dedicated cables are pre-fitted by the manufacturer. You see it is already there in place. So, and this is the mounting flange. This is the location where you can put your supplementary loads. Okay, you can put it here. This is the place where all the cables will go. All the cables will go. Now the floor is being prepared where you can build the riser or the concrete block on which this robot will go. So this is a complete structure for that. So this is there. So this is it. So you see, you have a concrete structure which is made up of size 700 by 700 because my robot was something, footprint size was 500 by 500 So I know my footprint size, so accordingly I have decided to put it by 700 by 700 Okay, so that sufficient clearance is there and I can push all my bolts through without breaking any of the edges. Okay, and the concrete structure was then standard 1045 1988, or there are other standards which are similar that specifies the concrete structure. There is no bars within this concrete structure because you have to put the mounting bolts or the anchoring bolts. I'll show you how they are fitted. This is one of them of M16 type, which you can see of tensile strength as specified by the robot manufacturer. Tightening torque is also given 206 Newton meter. It is different for different robots. Just for example, I am telling you, base plate is something 40 mm thick base plate which is there. Holes as per the robot's base. Okay, as per the robot footprint, you see it is there. Robot's base dimension. This I have extracted from the robot technical data sheet, and exact those holes are made over here. So this is the metal plate that will fit on top of this cement riser through grouting bolts, anchoring bolts, and the robot further will go on top of this. Okay, so this is how this structure is made. Okay, now I'll drill that concrete structure using this drilling machine, hammer drill machine. So this plate was put on top of this and I can just put some marker and do the drilling. Okay. So this is how the holes are made, you see. So the depth of the hole is as deep as this anchor bolt is. Okay. Concrete should be completely stiff before you actually do this. It should not be wet still inside. Now you can push in your, once all the holes are done, you can push in your anchor bolts. You can push it through. Okay, and then measure the clearance, tighten it before you actually put other bolts. This is the first one that is done, and the diagonally opposite one is now placed. First one is placed because this allows your plate to be firm enough while you are drilling other holes. This doesn't go off. Okay, so diagonally opposite one was chosen next. So that should be the sequence. Okay. So that also is put firmly now. These are anchor bolts. They doesn't come out if you pull it again or you tighten it further. Okay. So there are many such kinds which are available. Okay, of different makes. All the bolts are now put. I am quickly forwarding it now. Okay. Now all the bolts are fully tightened to the recommended torque, as I have discussed earlier, 206 Newton meter. Once it is fully tightened, now you can cut the extra part which remains. All the bolts are cut and properly grinded before it is put to use. Okay, now the robot can be placed on top of this metal plate. My robot was 150 kg, so it was easier doing this way. Otherwise you can have dedicated cranes which can take you there. Okay. So see, still that transport frame is still there, that yellow color one. Transport bracket is still there, shipping bracket, and that is later on removed. That helps you to pick up and place this robot itself. They are aligning the holes properly. Okay, so this is where your base plate is, then the anchor bolts are there and manipulator base that goes here. So this is how it is put. Complete details are here. The base plate mounting conical spring washer is there of M16 size. Okay. Okay. Yes, and now it is fully tightened one by one, all the hex bolts. Okay, now that all the bolts are tightened, visually it is inspected thoroughly, and so this is what is an spigot, that is the locating bolts. The reference spigots are pushed in properly so that it allows you proper alignment and precise robot operation. So while the robot is in use, it doesn't move. Okay. So now your robot is fully mounted. Okay, only mounted. So you see robot flange dimension is there before we actually put the gripper there. So it was masked properly using some adapter spacer also is there, so that properly matches the flange dimension of the robot to the flange dimension of the gripper. Okay, all the screws are placed. You should take care of the depth, which is mentioned in the data sheet also. Properly tightened to the torque which is specified there. Okay, now this is a 5x2-way solenoid valve. So that will actually actuate this gripper. So before it actually works, this is the compressor with FRL, 6 bar pressure, 50 liters tank capacity. So manual valve switching is done in order to see its operation, whether that finger is properly working or not, without actually controller is put to use. So you see this solenoid valve is mounted on the designated location on the first link, okay, so that it moves along with the robot. Okay, so this is the spot which is pre-marked and given in the manual that it has to be mounted here only. Okay, now this mounting bracket is removed, that is the shipping bracket, that yellow color frame. You see. Okay, so the controller cable outlet is connected here, that goes to the robot finally. Earthing cable is already connected here. Okay, this is the teach pendant. One end goes to the end of the teach pendant, other end goes to the controller. It is 3-phase socket. All the 3 phases are properly understood before it is actually put to the circuit breaker which is there. It may require a dedicated transformer to properly convert to the appropriate voltage level. In this case it is 220 volt phase to phase. Sometimes it is 440 volt for phase to phase. So you have to look for proper specification of the robot data sheet. So this is a 5-point plug with 3 phase, 1 neutral and 1 ground. The robot now can be started. It boots up. Initial configuration is done after that. All the IOs are connected. Now the robot is up. One by one, we'll test it for operation. Each of the axis is now made to move manually by jogging. Axis 1, 2, 3, 4, 5, 6. That's all. So now your robot is ready. Got it? So yes, that's all for this lecture. In the next lecture, we'll put this robot to use initially by mastering this robot so that it can be programmed and made to run. Now we have just jogged, we can program it. Before to that, we have to do mastering of the robot. Why that is required, how it is done, we'll discuss in the next class. That's all. Thanks a lot.